Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at simplifying radical expression with exponents. So let's go ahead and see if we can begin. I want to start by going with a proof here and try to see if I can make it clear exactly what's happening here. Imagine you have the following. You have 27y to the third power. Now we know from understanding the power exponent property that this is the same thing as 27 3y, because you could just multiply them together like so. Now here's the thing. Oh wait, I forgot to show you something. Let me back up. So let's say we have 27y to the third and that this equals 27. I know that's kind of weird. Now, knowing the exponent power property, 27y to the third power is going to be the same as this. 27 3y equals 27. That's something we studied in prior videos way back. Now, you already know again from prior videos that if the base is the same, which they are because this is basically 27 to the first power, but we never put the 1. So we can conclude that since the base is the same, when we're dealing with the exponents, we can just solve for the exponents, which means that 3y equals 1. And now this is just basic algebra. You divide both sides by 3, and then you get that y equals 1 over 3. Now, what does this mean? What this means is simple. If we go back to our original expression, which is up here, 27y to the third, this is what it means. It means very simply that 27 raised to the 1/3 power cubed equals 27. That's what it means. But wait, there's more. Another way that we can write this is as follows. We can write it as, again, we can write it as the cube root of 27 raised to the third power is going to give us the same answer. Or we can also write it as 27 to the 1/3, excuse me, that's a little bit too big, to the 1/3 equals 3 to the 27th, like that. All these will give you the same answer. And that's kind of what's happening here as we look at dealing with radical expression with fractions, is that what's happening here is that you can look at it from very different perspectives, and you have to make sure you understand that because that's critical. Now, what's happening is that whenever you get any of these forms, you can convert your radical expression to one of the following forms. It all depends on the situation and what you're dealing with. That's what we're trying to wrestle with in this particular situation. And going through this example here helps to make that clear. So let me see if I can do an even better job for you here. So imagine we got t to the 1/2. Well, that's not going to be too hard. That's going to equal square root of t, because the general principle is as follows. When a is a over 1 over n equals n with a inside the radicand like so. And so what's happening here is very simple. We got t as our n, so that's going to be our 2 right here. But remember, we normally do not write that when we're dealing with the square root. We only put the index when the index is greater than 2 normally. And so by doing that, you're able to quickly convert. Here's another example. When you have m to the 1/3, whoops, excuse me. If you follow our example here, well, our n this time is going to be 3, so that's going to be our index. And our a, well, looks like that's going to be m, so that's going to go right here, and we have our answer. Again, not that deep, not that complicated. If I had to give you a slightly more complicated example here, just for some fun, here is, we do it backwards now. So imagine we got the square root of 5y. This time, you can see that we have a variable with it, kind of like this second example, but not exactly the same. Oh, we have a variable with a constant, excuse me. And so, well, it's very, very, very simple here. The stuff inside the radicand is going to stay the same, but let's see here. It looks like there's no number here, so we know it must be 2. So we know that the bottom number is going to be 2 here, and the top number is going to be 1 for our exponent here. And so that's kind of how that works. And so this is kind of a pattern that you will commonly see. And to make it simple, the basic point is this. When you have a to 1 over n, you could make the n the index, and inside the radicand you put the a. That's kind of how it works. But there are, of course, variations on this. Another common variation that you will see is a m over n. That's going to equal the same as follows. So inside the parentheses, you're going to have the n as the index. You're going to have the a inside the radicand, and then you're going to have raised to the n power. So let me see if I can give you a couple examples of this. So let's say that we start with the following. We have the square root of y to the 7th power. All right. Well, if we follow this principle, because it's not that complicated, basically you're going to get y equals 7 over 2, like so. Y raised to the 7 over 2 power. That's kind of what's happening. But let me give you one that's a little bit more dramatic here. Again, this is all about following patterns. So imagine I have the cube root of cube root 5x, all that raised to the 4th power. Okay, well, if I follow my example here, well, let's see here. The n is going to be in the bottom. I'm going to have the same base, so it's going to be 5x is going to be my base. Looks like 3 is going to be the denominator, and then 4 is going to be the numerator. Oh, I'm sorry, 3. Why am I putting the 3? And then on top 4, like so. And so again, you can see there, not that amazing. Now, one last thing that I would like to show you is when you have a negative exponent. So the principle for that one, and I'm going to draw this for you first before we actually do it, is when you have a to the negative n, it equals the following: 1 over a to the n. So if you have a negative exponent, it becomes the base becomes the denominator raised to the positive, or you could say the absolute value of the exponent. So let me see if I can work this through for you in a very, very somewhat complex example. Not too bad, but somewhat complex. So imagine we have 25 raised to the negative 3 to 2 power. What that becomes is as follows. It becomes 1 over 25 raised to the 3 over 2 positive power, if you will. And so now what do? Well, we have to do what we kind of did on the previous slide, which was right here. We have this kind of a format now, and so we have to follow this. And so that becomes as follows. Let me just draw my little arrow here because I'm kind of working at a different thing. 1, and then right here I have square root of 25, and then on the outside I have 3, like so. That's what I have, and that's following that second example that I gave you on the previous slide. Now I need to simplify this, so I do the stuff inside the parentheses first. And so that leads to the following. I get 1 over 5 to the 3rd power. And then when I simplify this cube at the bottom, I get 1 over 125. And you can see that that's the final answer. And so again, this is just another situation you might encounter when you're trying to simplify radical expressions. So before we conclude, let me just kind of wrap up and re-explain what we looked at, and then we'll finish this video. So we started by looking at this principle of how to simplify radical expression with exponents. And so basically, the basic idea is that when you are dealing with exponents, essentially you can convert them into a fractional form or vice versa. So this example here, I took something that was raised to a particular power, and I figured out that, hey, I can also, if I raise it to a fraction of that, I'll get kind of the same idea there. And you can see how this works out in this example right here. And then you can go back and forth through the different ways of dealing with it. And it all depends on the situation. And we dealt with all of these in each of the next few slides, if you will. So right here we have the first principle that a raised to the 1 over n is going to be the same as the n root of a, if you will. And it's just a matter of following the pattern here. Again, you could check these by using numbers if you so desire, but this is how it works out here, like so. So t to the 1/2, well, 2 is going to be my index, t is going to be inside my radicand, and that's it. And so the m to the 1/3 is the same thing. And so you can convert your radical expressions back and forth between them being in a fractional form or in some other form like the root form. And then of course we did something a little bit more complicated where we started with the fraction and then we removed the fraction, if you will. So a to the m over n power, and then you have the nth root over with a raised to the n power. Again, this should look familiar because this was on the first slide, except it was using numbers rather than principles like this. And so we kind of worked on some examples here. So we have this one converted to y over 7 over the 2 power, and then a more complex example here where the absolute number becomes the numerator, the index becomes the denominator of the exponent, and then whatever's inside the radicand becomes the base. And then lastly, I showed you about when something is raised to a negative exponent. And so when that happens, you convert it, of course, to a fraction or vice versa. Remember, this works either way, back and forth. And so I gave you the example of 25 raised to the negative 3/2, if you will. And through following the arrows here, you can see we got 1 over 125. So that is what we covered in this video. I hope that what we talked about was reasonable and made sense, that we didn't move too quickly for you. So we learned about here how to simplify radical expressions, switching them back and forth between the exponent value, exponential value, if you will, and also the fractional value. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.